I want you to do something for me right now. I want you to stop watching this video for just 1 second, stand up, and walk to the nearest mirror in your house. It could be in the bathroom, the hallway, or on a closet door. Go stand in front of it. Look at yourself. Now raise your right hand. Look at your reflection. Which hand is the reflection raising? It is raising its left hand. The mirror has flipped you. It has taken your right and turned it into left. It has swapped the horizontal axis. You move east, the reflection moves east. You move west, the reflection moves west. But the handedness, the chirality, has been reversed. Now lower your hand, look at your head, look at your feet. Is your reflection standing on its head? No. The head is still at the top. The feet are still at the bottom. The mirror did not flip the vertical axis. Now ask yourself the question that drove Richard Feynman to giggle with delight and drove philosophers to madness for centuries. Why? Why does the mirror flip left and right but not up and down? Think about the physics of the situation. A mirror is just a flat sheet of glass with a layer of silver atoms on the back. It doesn't have a brain. It doesn't have a computer chip inside. It doesn't know about gravity. If you took that mirror onto the International Space Station, where there is no up or down, and you floated in front of it, it would still flip your left and right, but it would not flip your head and feet. And if you lay down on the floor on your side so that your left and right are now pointing up and down relative to the room, the mirror still flips your left and right relative to your body, but leaves your head and feet alone. What is going on here? Is the mirror smart? Does it have a preference for the horizontal, or is our brain playing a trick on us? Today we are going to solve the mirror paradox, but that is just the warm-up. That is just the appetizer. Because once we understand the geometry of the mirror, we are going to use it to ask a much bigger, much more terrifying question. A question that Feynman called the Ozma Problem. The question is this: if you were talking to an alien on a telephone, an alien who lives in a galaxy 1 billion light years away, an alien who has never seen a human, never seen a star map, never seen a compass, could you explain to him what the word left means? Could you describe the difference between left and right using only words and the laws of physics? For hundreds of years, scientists, Newton, Maxwell, Einstein, said no. They said the universe is perfectly symmetrical. They said left and right are just arbitrary labels we humans made up, like clockwise or counterclockwise. They said physics doesn't care. They said that if you built a machine that was the mirror image of a car engine, it would run just as well. But Feynman is going to show us that they were wrong. He is going to show us that the universe does care. He is going to show us that the universe is, quite literally, left-handed. There is a screw in the fabric of reality. And if you ever meet that alien and he extends his left hand to shake yours, you should run for your life. Let's start with the mirror. Let's solve the paradox of the reflection. Imagine you are standing in front of that mirror again. You hold up a piece of paper with text on it. You wrote the word hello. When you look in the mirror, it reads ole. The letters are backward. The H looks the same, but the E and the L are flipped. We usually say the mirror reverses left and right, but does it? Let's test this hypothesis. Imagine you point your finger directly at the mirror. Where is your reflection pointing? It is pointing directly back at you. Now imagine you point your finger to the north, let's say to your right. Your reflection points to the north. You point to the east. Your reflection points east. You point up toward the ceiling. Your reflection points up toward the ceiling. You point down toward the floor. Your reflection points down toward the floor. The mirror is actually telling the absolute truth about up, down, left, and right. If you move your hand to the east side of the mirror frame, the reflection moves to the east side of the glass. The mirror is not moving things sideways. So where does the flip come from? Why does the E look backward? Feynman explains it with simple geometry. The mirror does not flip left and right, the x-axis. The mirror does not flip up and down, the y-axis. The mirror flips front and back, the z-axis. Imagine you are holding a squishy rubber ball. You paint the front half blue and the back half red. You throw it at the mirror. It hits the glass and squishes flat. The front of the ball, blue, is touching the glass. The reflection of the ball also has its blue side touching the glass. The back of the ball, red, is facing you. The reflection's red side is facing away into the mirror world. The mirror acts like a crushing machine. It takes the depth of the world and inverts it. Everything that is pointing toward the mirror gets reflected back toward you. So why do we think it flips left and right? Why do we swear that the hand changed sides? Because of human psychology. Because of how our brains process social information. We are symmetrical creatures. We have a left side and a right side that look almost the same. We have an arm on each side, a leg on each side, an eye on each side. But our front, face, chest, and our back, spine look totally different. When we look into a mirror, our brain tries to make sense of the person looking back at us. We treat the reflection as if it were another human being standing in a room behind the glass. We subconsciously ask, how did that person get there? Our brain answers, oh, that's a person who walked around behind the glass and turned to face me. Now think about the geometry of turning to face you. To turn and face you, a real person would have to rotate their body 180 degrees. If a real person stands next to you and then rotates 180 degrees to face you, their right hand would swing around and end up on your left side. Their left hand would end up on your right side. So when we look at the reflection, our brain expects that rotation. But the reflection is not a rotated person. The reflection is a front-to-back inverted person. When we see the reflection raising its hand on the same side as us, right side of the glass, our brain says, wait, if that was a real person who rotated, they would be raising their left hand, but this image is raising the hand on the right. So the mirror must have swapped their hands. The mirror didn't flip left and right. The mirror flipped depth. Your brain rotated the image mentally to try to make sense of it, and that mental rotation caused the left-right confusion. If you don't believe me, lie down on the floor in front of a mirror. Now up and down are along the floor. Left and right are vertical. The mirror will still show your reflection lying down. It doesn't care about gravity. It only cares about what is in front of it. If you hold a text up, it is still backward because the text was flipped front to back. Imagine the word hello printed on a transparent sheet of plastic. If you turn the plastic sheet around, rotate it, the letters reverse. The mirror is showing you the back of the letters. So mystery solved, mirrors flip front to back. The confusion is psychological. Physics is safe. Symmetry is preserved. But Feynman doesn't stop there. He uses this mirror paradox to launch into one of the deepest investigations in the history of science. He asks the deeper question, is the world in the mirror a possible world? Imagine we had a magical 3D printer, and imagine we could print a physical copy of everything we see inside the mirror. We build a car where the steering wheel is on the right side instead of the left. We build a clock where the numbers go counterclockwise, 12, 11, 10. We build a DNA molecule that twists to the left instead of the right. We build a human being whose heart is on the right side of the chest, whose liver is on the left, whose appendix is on the left. Now the question is, would this mirror world work? Would the car drive? Would the clock tick? Would the human live? For a car, obviously, yes. In England and Japan, cars are already mirror images of American cars. They work fine. For a clock, yes. It would just tell time backwards, but the gears would mesh perfectly. For a human heart, yes. There is a medical condition called situs inversus, where people are born with their internal organs flipped. Their heart is on the right, and they live perfectly normal, healthy lives. Their biology works. It seems that the laws of physics are mirror invariant. They don't care about left or right. Gravity pulls things down, not left. Electromagnetism pushes charges apart, not right. Strong nuclear force holds atoms together symmetrically. If you took a video of a physics experiment, billiard balls colliding, planets orbiting, pendulums swinging, and you played that video in a mirror, you wouldn't be able to tell it was a mirror. It would just look like a valid experiment happening in a slightly different way. A mirror planet would orbit just fine. This leads us to the ultimate test, the alien phone call. Feynman sets the stage for a thought experiment that tests the limits of our knowledge. Imagine we make contact with a civilization on planet X. They are 1 billion light years away. We cannot visit them. We cannot send them physical objects. We cannot send them pictures, because to send a picture, you have to scan it from left to right. And if you don't agree on left, the picture comes out backward. We can only talk via radio pulses, binary code, beep, silence, beep. We want to tell them about us. We want to teach them our science, and we want to describe what humans look like. Step 1, mathematics. This is easy. We pulse, beep, 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 beep. 1, 2, 3. The alien understands. Math is universal. Step 2, chemistry. We describe the periodic table. We are made of the element with 6 protons and 6 neutrons. The alien checks his periodic table. Ah, carbon, we have that too. Step 3, biology size. We are about 10 atoms tall. The alien calculates the size. Okay, you are about 2 meters tall. We get along great. We explain our civilization. We explain our cars, wheels, engines. We explain our history. But then we try to describe our anatomy. We say, we are symmetrical on the outside, but inside we have a heart, and we put our heart on the left side of our body. The alien pauses. The radio signal stops. Question, the alien sends back. What is left? You freeze. You are sitting in mission control. You have all the physics textbooks in the world. You have Einstein's notes. You have Newton's Principia. How do you explain left? You say, well, left is the side where the heart is. The alien says, I don't know where my heart is. I don't look like you. I am a sentient cloud of gas. I don't have a left or right side. I need a definition based on the laws of the universe. You start to sweat. You say, okay, imagine you are standing on a spinning planet. The alien says, which way is it spinning? Clockwise or counterclockwise? You realize you can't define those words without defining left and right first. It's a circular definition. You try biology. If you eat sugar and the bacteria digest it, the alien stops you. We have bacteria here, but maybe our bacteria are the mirror image of your bacteria. Maybe on my planet the sugar twists the other way. If I use your definition, I might be describing right. You try electromagnetism. You think you have it. You remember high school physics. You remember the right-hand rule. You say, take a copper wire, run electricity through it, put a compass needle under it. The north pole of the needle will point left relative to the current. The alien builds the wire. He runs the current. He puts the compass there. But then he asks, wait, which end of the magnet is the north pole? I have a bar magnet. One end is painted red, one is blue. But those are just labels. How do you distinguish north from south physically without pointing? You realize with growing horror that you cannot do it. We define north as the way the earth points. But the earth could have spun the other way. We define positive charge as what protons have, but we could have called it negative. The labels are arbitrary. If the alien built a machine based on your instructions, but he accidentally built the mirror version, swapping all your lefts for rights and norths for souths and positives for negatives, it would work exactly the same. He would never know he made a mistake. There is no force of leftness in the universe. There is no signpost in the cosmos that says this way is left, or so we thought. For hundreds of years, this was the absolute dogma of physics. It was called the conservation of parity. It meant that the universe has no preference for left or right. It meant the mirror image of reality is just as real as reality. But in 1956, 2 brilliant physicists named T.D. Lee and C.N. Yang proposed something crazy. They looked at some weird data from particle decays, and they said, maybe the weak force breaks the mirror. The weak force is one of the 4 fundamental forces of nature. It is the force that causes radioactive decay. It is the force that turns a neutron into a proton. It happens deep, deep inside the nucleus. Lee and Yang suggested that maybe, just maybe, deep down in the subatomic world, nature does have a favorite hand. They went to an experimental physicist named Chen-Shung Wu, Madame Wu. She was one of the greatest experimentalists of the 20th century. She was known as the Queen of Nuclear Research. They asked her to test the universe. Madame Wu set up an experiment that was incredibly difficult. She used cobalt-60 atoms. Cobalt-60 is radioactive. It is unstable. It wants to decay. When it decays, it spits out an electron. This is called beta decay, and turns into nickel. But cobalt-60 atoms also spin. They act like tiny little magnets, spinning on an axis. Normally, the atoms are spinning in random directions. But Madame Wu cooled the cobalt down to near absolute zero, 0.03 Kelvin. It was one of the coldest places in the universe. She did this to stop the thermal jittering. Then she turned on a massive magnetic field. This forced all the cobalt atoms to line up. Think of them like a regiment of soldiers or a field of spinning tops, all spinning in the same direction. Now the stage is set. We have an up and a down defined by the magnetic field and the spin. The question is, when the cobalt atom spits out the electron, which way does it go? Does it go up out the top of the spin? Does it go down out the bottom of the spin? If the universe is symmetrical, if parity is conserved, it shouldn't care. The electron should be just as likely to pop out the top as the bottom. It should be 50-50, or it should shoot out the side. If you watch this in a mirror, the spin would reverse, and the direction of the electron would reverse, and the physics should look identical. Madame Wu ran the experiment. She watched the detectors, and the universe dropped a bombshell. The electrons came out the bottom, almost all of them. They had a preference. They knew which way the atom was spinning, and they chose to exit the back door. This is hard to visualize, so let's use the hand rule. If you curl the fingers of your left hand in the direction of the cobalt spin, your thumb points down, the direction the electrons go. If you try to use your right hand, it doesn't work. The thumb points the wrong way. Cobalt-60 is left-handed. The weak force is left-handed. The mirror is broken. Parity is violated. If you built the mirror world, the world where everything is flipped, Cobalt-60 would behave differently. In the mirror, the spin looks reversed. So the mirror cobalt would shoot electrons out the top. This means the reflection in the mirror is not a possible world. If you built a mirror image car, it would run. But if you built a mirror image cobalt atom, it would fail the test. It would violate the laws of physics of our universe. Feynman was amazed. He said nature had a screw in it, a preferred direction. God is a lefty. This meant we could finally call the alien back. The Ozma problem was solved. Hello, alien? Are you still there? I have the answer. Great, says the alien. Tell me what left is. You say, okay, forget the biology, forget the compass, do some nuclear physics, take some cobalt-60 atoms, cool them down to near absolute zero, put them in a magnetic field, line up the spin. Now watch where the electrons come out. The alien says, okay, I see them coming out. You say, great, the direction the electrons are coming out, call that down. Now stand so your feet are pointing down in the direction of the electron stream. Look at the direction the atom is spinning. That direction is left. The alien follows the instructions. He builds the experiment. He watches the electrons. He defines down. He looks at the spin. He defines left. It works. The definition is anchored in the fundamental structure of the weak force. We have successfully communicated left across the galaxy using only the laws of physics. We have anchored our reality, but, and with Feynman there is always a but, there is a twist, a terrifying twist that brings us to the edge of destruction. Feynman, ever the trickster, adds one final warning to this story. This experiment works perfectly, assuming one thing. It assumes the alien is made of matter, but we know that for every particle of matter, there is an antiparticle, antimatter. And we know that antimatter behaves like the mirror image of matter in almost every way. This is called CP symmetry, charge parity symmetry. If you flip the charge, matter to antimatter, you also flip the parity, left to right. So imagine the alien is actually made of antimatter. He lives in an anti-galaxy made of anti-stars. When he gets our instructions, he goes to his lab. He doesn't take cobalt-60, he takes anti-cobalt-60. He cools it down. He lines up the spin. But because he is using antimatter, the laws of physics are flipped for him. His anti-cobalt atoms shoot the positrons, anti-electrons, out the top. The anti-weak force is right-handed. So when he follows our instructions, call the direction of the electrons down, he is actually calling up, down. And when he looks at the spin to define left, he is looking at it upside down. He will define right as left. He will get the definition exactly backwards, but he won't know it, and we won't know it. So here is Feynman's final piece of advice, a survival guide for the cosmic age. Imagine you finally develop a spaceship. You travel at warp speed to the alien's planet to meet him. You land on the surface. You open the hatch. The alien walks toward you. He looks exactly like the description. He is 2 meters tall. He has built the car. He has built the clock. He seems friendly. He smiles. He extends his hand to shake yours. If he extends his right hand, you are safe, because if he extended his right hand, it means he correctly understood what right was, which means his cobalt experiment worked the same way as ours, which means he is made of matter like us. But if he extends his left hand, do not touch him, because if he extends his left hand thinking it is his right hand, it means he got the definition backward, which means his cobalt experiment went the wrong way, which means he is made of antimatter. If you touch him, even for a microsecond, the matter in your hand and the antimatter in his hand will react. You will both instantly annihilate. You will turn into pure energy. The explosion will be brighter than 1,000 suns. The entire landing site will be vaporized. The mirror paradox isn't just a trick of the light in your bathroom. It is the fundamental test of reality. It tells us that the universe is not a perfect sphere. It has a grain, it has a texture, it has a left and a right, and it tells us that symmetry, the idea of perfection, is just a beautiful lie we told ourselves until we look closely enough to see the truth. The universe is flawed, it is lopsided, and thank goodness for that, because if it were perfectly symmetrical, the Big Bang probably would have produced equal amounts of matter and antimatter, and they would have annihilated each other instantly, and there would be nothing left to look in the mirror. We exist because the universe is left-handed.